In this video, we're going to do another example where we graph some linear equations. We're going to do two examples, y equals 2x plus 1 and x minus 4 equals negative 2y. And remember, as always, we know that these are linear equations because, first of all, they have equal signs, so we know that they're equations. And we know that they're linear because both of the variables, x and y, are first degree variables, meaning that we have y to the first power and x to the first power. So they're first degree variables. That means that the equation is going to be linear, which means its graph is going to be a line. Now remember, you can always use two methods to graph the equation of a line. You can find coordinate points along the line, plot those coordinate points, and then connect them to draw the graph of the line. That's what we're going to do in this first example. Or in the second example, you can put the equation in slope-intercept form. In other words, you can make the form of the equation match this equation here, y equals mx plus b, because if you can get the equation in that form, which is called slope-intercept form, then you can identify m, which is the slope of the line, and b, which is the y-intercept, meaning the point at which the graph intersects the y-axis. So let's start by plotting points for y equals 2x plus 1. If you're going to plot points, you always want to pick for x a negative value, 0, and a positive value at least. We'll use -1, 0, and +1. That's pretty standard because they're usually pretty easy to find. So we're going to plug these values for x into this equation for y to find the associated value for y. So plugging -1 in for x, we're going to get y equals 2 times -1 plus 1. That'll give us y equals 2 times -1 is -2. Plus 1, so we get y equals -2 plus 1 is -1. So we get -1 there. Plugging in 0, we'll get y equals 2 times 0 plus 1. Y equals 0 plus 1, or y equals 1. So y equals 1, and then plugging in 1, we're going to get y equals 2 times 1 plus 1. Y equals 2 plus 1, or y equals 3. So we get 3 here. Now we can just plot these points on our coordinate axes. Remember that this is the x-axis, that this is the y-axis, this is the positive direction of the x-axis and the positive direction of the y-axis. So when we say -1, -1, we mean go in the negative direction of the x-axis 1 unit, and then go in the negative direction of the y-axis 1 unit, and we get the point -1, -1. Plotting the point 0, 1, we have 0 for x and then +1 for y, which is right there, and then 1, 3, going along the positive direction of the x-axis 1 unit, and then 3 units in the positive direction of the y-axis puts us right here. And then if we connect those points, we can see that we have a line that looks roughly like this. And so that is going to be the equation, or the graph, I should say, of y equals 2x plus 1. And this should make sense to us because our slope, this equation, is already in slope-intercept form. We can see that this is the slope, m, and that this is the y-intercept, b equals 1 here. And if we look at our graph here, so we have a slope of +2, and we know that when our slope is positive, our equation will slant up and to the right here. It'll slant to the right, so we know that that looks right. And then we said that the y-intercept was 1, and we can see that our graph does intersect the y-axis at 1. So this looks like it should be the graph of y equals 2x plus 1 if we compare this to slope-intercept form, even though we just plotted coordinate points. Now let's look at our second example, x minus 4 equals -2y. Instead of just plotting points, we'll instead change this into slope-intercept form, and then just use the slope and the y-intercept to sketch the graph of the line. So we need to solve this for y, which we'll do by dividing both sides of the equation by -2. We're going to get y equals -1/2 x, and then -4 divided by -2 is +2, so we'll get +2. Now we can see that our slope is -1/2, and that the y-intercept of this equation is 2. So we're going to start with the y-intercept, and we're going to plot that here at 2. So the graph intersects the y-axis at y equals 2, so we plot that. Then we use our slope to sketch the rest of the line. So this slope is -1/2. -1/2, remember, can be expressed as -1 over +2, or as +1 over -2. Both of these things are equal to -1/2. And this is helpful because let's first use this slope here, -1 over +2. That means, because remember, slope is m equals change in y, or delta y, over change in x. So when we say negative 1 over positive 2, that means the change in y is negative 1. That means go down 1 along the y-axis, and then change in x is positive 2. So that means go over along the x-axis in the positive direction 2 units. So when we say negative 1 over positive 2, we mean down 1 and over 2 this way, down 1 and over 2, like this. If, on the other hand, we use this slope, positive 1 over negative 2, that means go up in the positive direction of the y-axis 1 unit, and then go over to the left in the negative direction of the x-axis 2 units. So this means up 1 and over 2 this way, up 1 and over 2 this way. So we get these points, and then we can go ahead and connect them with a line that looks roughly something like this. And we can say that that is the graph of the equation x minus 4 equals negative 2y, which of course we know is the same as y equals negative 1/2 x plus 2. So those are just a couple more examples of how to sketch the graph of a linear equation.